Hello everyone. Let's start the discussion of NLM. And this is question number one. Now here the question number one. A mass M three-dimensional space F1, F2, F3. So what they were saying, there is a three mass. Let's say three dimension. This is a plane. F1, F2 have a same magnitude, and F1 it is acting along the positive. And this is F1, and F2 this is F2 positive y. If the mass has acceleration 0, so let's say some mass is there. They have given F1, F2, F3, and we have information of F1, F2, and the F1, F2 acting on mass M, and the total force we don't know about where the F3 it will be placed, so that acceleration of a whole system will be 0. So you can think that way, if by Newton's law F net is equal to ma, if a is 0, mass will never going to be 0. That means F net should be 0. And when the F net will be 0, since we have given two direction of x and y, clear? So we can say this is xy direction. If the resultant acting in xy, and let's say what is the resultant of F1 and F2, so this is the resultant of F1, F2. We have to cancel this force. So of course it will be acting just opposite to it in the same plane. Then resultant force will be 0. So we can say the resultant of F1, F2, fine. If opposite force acting to balance it, net force will be 0. So in that case, magnitude of F3 is same as that of F1. This is incorrect because the resultant will be equal to the object in equilibrium and could be stationary. So here we have to express which statement is false. And kindly notice, in examination you usually commit mistake. For the sake of true option you start searching, and for the false option even then you are searching true. So please keep noting the false statement. So I thought false statement, the object is in equilibrium and could be stationary. This may be could be stationary as well. F3 lies in xy. This is look like also the object in equilibrium and could be moving. This is also look like correct. The object is experience net force equal to 0. This is also look like net force is 0 only. Now the magnitude F3 is same as F1. Now whatever the F3 it is there, that is equal to F1. Fine. So here we can say the correct option is, because that is false only. The rest of the statement it is, we can say rest of the statement is true, because these statement has a possibility it will be true, and we have to collect false. So I thought A is incorrect. That is false. So let's move to the question number two. Now you can read the question. Now here what the question situation is, this is rotating and this person is stuck with this wall. Stuck with this wall means this will be having, like, this is a circular motion it will be executing. And let's make a free body diagram quickly. So we can say mg downward direction, and just opposite to it some friction force is acting, and normal to it, of course, normal action, and for the sake of movement, that is centrifugal force acting. And since it is stationary, so always remember stationary means leftward force and rightward force should be equal. So n is equal to mv square by r, and upward force is equal to downward force. So that is Fr is equal to mg. What is Fr? Mu into n is equal to mg. So mu, what is n here? It will be mv square by r, that is equal to mg. M and m get cancel out. Now we can get mu, in place of v we can put r omega ka square divided by r, that is equal to g. So we have to calculate the value of omega actually. So 1 r, and from r square 1 r get cancel out. So it will be g upon mu upon r under root, that is the value of omega. So here the most important thing is we have to balance the forces, and this is equilibrium situation. Always remember equilibrium. Equilibrium. So let me explain quickly what is equilibrium situation. Equilibrium will be of two type actually. Net F, if we can say, if F net is equal to 0 and F top equal to 0, this is a condition of equilibrium. So equilibrium, we can say acceleration, as you know, net F is equal to ma, and net torque is equal to I alpha, angular rotation. So here if a is 0, we can say we can reach to the situation. If alpha is 0 means no rotation, so we can reach to this situation. This is called equilibrium situation. Clear? Now the next problem look like very simple. Now the most important in NLM, you better to take a approach by free body, FBD. So here we can say mg and theta, so it will be theta, so mg cos theta, mg sin theta, normal reaction it is acting, and just friction force is acting. And since the body is moving in the given direction, so let's take this direction as a positive. So it will be mg sin theta minus fr is equal to m into a. This is equation, and that is along wedge. This is a long wedge, and perpendicular to the wedge, it is n is equal to mg cos theta. So by using these two equations, we can calculate whatever it is demanding. So this is called free body diagram situation. Always remember. Now here once again we have to resolve, because this is a tension, and since this is spring force, let's say spring force, this is a string, string tension, and this is weight. So once again, this is the, always remember, once we will make a plus at the intersection. So if it is balance means left hand force equal to right hand, upward force equal to downward force. So once you are keeping equal, whatever they will demand, you can get at once. So this is very similar type. Now this is once again that is called force of interaction. So if this type of problem it will come, you better to get step one, calculate common acceleration, and common acceleration what is external force, since F is equal to ma. So A is equal to F by m. This is F total, m total. What is F total? F applied divided by m total, 3 or 4, 7. This is a common acceleration. Once you get the common acceleration, step 2 should be, now step 2, make a free body diagram. Let's say 4 kg free body diagram. One force is acting and normal contact, that is internal force acting, mg, and normal reaction. Let's say m dash. But we are talking about the horizontal direction, so here we can say F minus n is equal to 4m into a. By this way we can calculate the, this is normal, because F applied they have given, to F minus 4 mg m into a, that is normal reaction. So by this way we can calculate the normal reaction value very easily. Clear? Now likewise, one more question is there. This is one of the good question. The possibility in this type of problem it will come. So here once again you have to calculate AC is equal to F upon total force 3 to 5 and 6, and this is a common acceleration. Common acceleration means all the block will moving with the same acceleration once they are moving together. So if we are talking about the individual block, so what is F net? F net on small m is equal to m into AC. AC is F by 6m, and similarly 2m into F by 6m and 3m into F by 6m. Now here F, F net it will be m and m get cancelled out, F by 6. Clear? In the second, m and m get cancelled out, 2m by 6, or we can say F by 3, and here 3 to the 6, F by 2. So these are the force, that is resultant force acting. Now the acceleration of a block vary according to its mass. I thought this statement is look like, here we have to check on mass. So here the mass get cancelled out, otherwise this statement is incorrect. The acceleration of each block is F by m. This is also not correct. The net force acting on a block is, on each block is same. So here it look like, is it look like same? All are different. So this is also not correct. Now magnitude of 3m block is from 2m block is greater. So here you can see F by 3, F by 2. Which force is greater? The 3m from 2m. The magnitude of force 3m and 2m is greater than the magnitude of, now here you can check these are the magnitude, so this will be not equal. Apart from it, this is look like not. Now the Last statement, force 3m is thrice greater than the net force on m. So 3m, it is F by 2, and net force 3m is greater than the net force acting, and m I thought m by 6. So here we can say the first block multiply by 2. Force acting 3m is thrice. If we multiply by 3, so it will be 2. So I thought this statement is correct. So by this way you can approach this problem. So, so these are the few area that you better to check in LNM. And NLM, we can say only few things you better to remember. Number one, you have to use net F is equal to MA. Second, net F is equal to 0, so that is equilibrium situation. 3, make a free body diagram. 4, you have to resolve on X. This is the resolving you needed. And fifth, friction force is equal to mu into N, where N it will depend upon surface. Once it is a horizontal surface, it is acting equal to mg, but once it is an inclined surface, then normal reaction is equal to mg cos theta. So these are the few things if you remember, so you can manage your numerical very easily. So keep doing your preparation. I will keep uploading the following videos like work energy, few important area of rotation as well. Okay, then take care. Have a nice time. All the best.